Beginning with man's first attempt to fly faster than the speed of sound, the National Aeronautics and Space Administration's Flight Research Center has played an important role in establishing this country's leadership in world aeronautics. The Flight Research Center was established in 1947, when a small group of engineers and technicians were assigned to the X-1 flight research program. Since then, the specially designed and highly instrumented research aircraft has become one of the most valuable tools of advanced aeronautical research. The X-1 was the first research aircraft to fly faster than the speed of sound. Its mission was to probe the sound barrier. Powered by an XLR-11 rocket engine rated at 6,000 pounds of thrust, it used propellants of ethyl alcohol and liquid oxygen. The X-1, air-launched from a B-29 mothership, made its first powered flight in 1946. In 1947, Captain Charles Yeager piloted the X-1 in level flight faster than the speed of sound. The D-558 Skyrocket was the second rocket-powered research aircraft to fly. It was designed to investigate jet aircraft characteristics at transonic speeds, including stability and control and buffet investigations. The D-558 was the first American aircraft to use swept-back wings and stall fences, features that are common to our present-day commercial jet transports. The D-558 was the first aircraft to fly faster than twice the speed of sound. The largest of the early research aircraft was the X-3 Stiletto. It was 69 feet long with a wingspan of 22 feet. The primary mission of the X-3 was thin wing research. Powered by two jet engines, the X-3 had a top speed of slightly in excess of Mach 1, the speed of sound. The X-4 was easily recognizable by its lack of a horizontal tail. The X-5 was the first aircraft that could sweep its wings from 20 degrees to 60 degrees in flight. This variable sweep concept is being used in current fighter and bomber designs. The X-5 made its first flight in 1951. First flown in 1955, the X-1E was used for thin wing research, aerodynamic heating studies, and stability and control investigations. The most successful of the research aircraft was the X-15, which made its first powered flight on September 17, 1959. The three X-15 aircraft flew 199 flights to obtain data on the aerodynamics of hypersonic flight. The X-15 is the only manned aircraft that has flown to altitudes of 354,200 feet and speeds of Mach 6.7. The flight program made significant and unique contributions to future aircraft designs and proved that winged Earth exit and re-entry are well within the control capabilities of man. The XB-70, the world's largest experimental aircraft, was 185 feet long, had a wingspan of 105 feet, and was 30 feet high at the tail. It was capable of flight at speeds of 3 times the speed of sound, 2,000 miles per hour, at altitudes of 70,000 feet. The major objectives of the XB-70 flight research program were to study the airplane's stability and handling characteristics, evaluate its response to atmospheric turbulence, and assess propulsion system performance. The wingtips could be lowered in flight to allow the aircraft to cruise at higher speeds more efficiently. At these higher speeds, water vapor condensed at the forward control surfaces. The vapor can be seen streaming from the aircraft. A program to develop the piloting techniques that were used during the final phase of the manned lunar landing was started at the Flight Research Center in 1964. This program used a free-flying simulator called the Lunar Landing Research Vehicle, or LLRV. To compensate for the gravitational and atmospheric differences between the Earth and the Moon, the LLRV was equipped with a gimbaled jet engine that produced enough thrust to counterbalance 5/6 of its weight, thereby simulating 1/6 gravity of the Moon. Small rocket motors were used by the pilot to control horizontal and vertical movement in a simulated approach to the surface of the Moon. One of the research craft recently tested at the Flight Research Center was the M2 lifting body. The M2 was towed to altitude by a C-47 aircraft. Lifting bodies are wingless vehicles that obtain aerodynamic lift for flight from the shape of their bodies. Vehicles like these are being tested to obtain basic flight test data to aid in the development of future space shuttlecraft that will be used to supply men and materials to orbiting space stations. 3 minutes after launch, the M2 began its final landing approach. Total flight time for a normal glide flight was almost 4 minutes. The HL-10 was the second manned research craft of the wingless lifting body class of re-entry vehicles studied by NASA. It was flight tested to provide technology for the design of future spacecraft that are maneuvered in flight to normal landings at selected landing sites. During the final approach, the HL-10 pilot pushed over to increase the horizontal speed before performing the flare maneuver to cushion the landing. The HL-10 landing speed was about 230 miles per hour, and rollout was approximately 1½ miles. The X-24A was another of the 3 lifting body shapes which had been flown at the Flight Research Center. First flown on April 17, 1969, the craft made 28 flights. Top speed reached by the X-24A was 1,000 miles per hour, and the highest altitude was 71,000 feet. A new airfoil shape called the supercritical wing is being flight tested aboard an extensively modified F-8 jet aircraft. Almost the direct opposite of conventional airfoil shapes, the supercritical wing has a flattened top surface which delays shock wave formation and increases the total wing efficiency. An advanced flight control system called the Digital Fly-by-Wire System has been installed by the Flight Research Center in a modified F-8 jet aircraft. The heart of the control system is a digital computer and an inertial measuring unit that were developed for the flight control system of the Apollo lunar module. Use of this kind of control system could make air travel of the future smoother and safer by reducing aircraft vibrations caused by turbulent air through automatic response from the computer to the aircraft controls. The National Aeronautics and Space Administration has assumed operational control of 2 YF-12 aircraft being flown in a joint Air Force-NASA research program. The basic purpose of the YF-12 flight research program is to obtain information from sustained cruise flight at Mach 3, approximately 2,000 miles per hour, at altitudes near 75,000 feet. Data obtained from the program will be used to further the development and operation of supersonic aircraft, both commercial and military, and the proposed space shuttle. Major areas of interest in the NASA portion of the program are structural and performance research. Other research regions include stability and control, aerodynamics, the physiological and biomedical aspects of sustained high-speed cruise, and the physics of the upper atmosphere. Future aircraft design will depend on the work we do here today at the NASA Flight Research Center. And so, after 25 years of basic research into all the facets of manned flight, the NASA Flight Research Center is ready for the challenge of tomorrow, looking forward to new horizons to conquer. Programs are under consideration which will tax present knowledge and demand solution by the youth of tomorrow.